Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking a 6 microcoulomb charge is placed at the origin and a negative 4 microcoulomb charge is placed 2 meter to the right. A third negative 8 microcoulomb charge is placed on the y-axis 2 meter above the first charge. What is the force on the second charge due to the other two? Okay, now let's go ahead and draw this one in a diagram. Okay, let's say here we have our y-axis, here we have our x-axis, and in the origin we have a charge. Okay, let's see what's that charge is. 6 microcoulomb charge is placed at the origin. So this is a positive charge, since this is positive, like positive charge given right here. So this is going to be a positive charge, so we are going to put a plus, and this is at the origin, and that is equivalent to, let's call this one q1. Q1 is equal to 6 microcoulomb. Okay, now let's look at the second charge, and a negative 4 microcoulomb charge is placed 2 meter to the right. So here we have a negative charge placed, let's call this one q2, that is equivalent to negative 4 microcoulomb, and that is placed 2 meter to the right. Okay, a third negative 8 microcoulomb charge is placed on the y-axis 2 meter above the first charge. So 2 meter above the first charge, here we have a negative charge, and the value of the charge is going to be what? Negative 8 microcoulomb. So this is from here to here, it's 2 meter. Now the question here is asking what is the force on the second charge due to the other two. So we are trying to find the force on this charge due to these two charges. Now let's try to figure it out. So we have to know that when we have opposite charges, they will attract each other. So we will have a force from this charge in this direction. Let's call this one F12. Since it's related to the first charge and the second charge, we can call this one F1 and 2. And also we have another force due to this charge. We are interested in finding the force on the second charge due to the other two. So we are going to have a force on this negative charge due to this negative charge, but when we have equal charges, they are going to repel each other. So we are going to have the force on this direction. So let's call this force F2. Since this is 3, let's call this one Q3. Since this is 3, let's call this one F23. So we are interested in finding these two charges, and finally we will end up with the resultant force. Like the total force is going to be the resultant of these two charges, these two forces, and that's going to be somewhere here, and that's what we are interested in. That's what Ft is. That's what we want to find. Now let's go ahead and find the F12 first. To find that one, we can use this equation. F is equal to k q1 over r square. F is equal to k is what? K is 9 times 10 to the power of 9 times the first charge, since we are doing plus and this minus, and also we are trying to find the magnitude. Let's call this one F12, and the magnitude is what we are interested in. So this is going to be 9 times 10 to the power of 9, and this is 4 microcoulomb. So 4 times 10 to the power of minus 6 times 6 microcoulomb, 6 times 10 to the power of minus 6 divided by the distance, that is 2 meter. So this is going to be 2 square. Okay, and if you calculate this one, you are going to get 0.054 Newton. 0.054 Newton in the x direction, and this is in the negative x direction, so we are going to have negative. Okay, now let's see. Let's look at the next one. This is 1, 2, and now we are interested in finding F23. F23 has two components. It has x component and y component, because this is not exactly in the y-axis or exactly in the x-axis, it's in the middle, right? So we are going to have two components. Now we have to find the two components. Okay, let's move this one to the top, because this might confuse. F12 is right here. Okay, so Ft is what we are interested in finding, but first we have to find F23. F23 has two components, and if we find the magnitude, then we can find related to the components, right? So first let's go ahead and find the magnitude of this one. To find the magnitude, first of all we have to know the distance, this distance right here from here to here. Let's use a different color. We have to know the distance from here to here. This is 2, this is 2. So using Pythagorean theorem, we are going to have this distance, that's going to be 2 square plus 2 square. So 4 plus 4, square root of 8. So that's going to be what, 2 root 2 meter. So that's going to be this distance. Let's call this one r. R is equal to 2 root 2 meter. So we are going to use this distance in order to find out the F23. So let's go ahead and find F23. F23 is going to be k q1 q2 over r square. K q1 q2 over r square. Let's call this one r23 square. So this is going to be 9 times 10 to the power of 9 times q1 is what? Oh, this is 2, 3. Since we are interested in finding the charge due to 2 and 3, this is going to be 2 is 4 times 10 to the power of minus 6 times 3 is 8 times 10 to the power of minus 6 divided by the distance, that is square root of 8 whole square. Okay, and if you calculate this one, you're going to get 0.036 Newton. Okay, so that's going to be the F23, but since it has x and y components, we have to find both of them, because to find the total charge we have to express in terms of xy component, and also to find the magnitude of the total force we need the xy components. Okay, so first of all, let's go ahead and find, this is F23 and this is magnitude. Now we want to find the x component. To find the x component, first we have to know the angle. We are interested in finding this angle. This is F23, right? So we are interested in finding this angle that is making with this horizontal. To find this one, we can find this angle first. If you find this angle, that's going to be equal to this, and you can see this is z shape. So this angle is equal to this angle, and this angle is equal to this angle. So since we know this is a 2 meter, so tan and opposite and adjacent are 2 meter, right? So tan theta is equal to 2 over 2, that's equal to 1. So theta is equal to tan inverse 1, that is equal to 45 degree. So this is a 45 degree angle. 45 degree angle. Since we know the angle, we can find the x and y component. Let's go ahead and find the x component. F23 x component is going to be 0.036 cosine 45. That's equivalent to what? Cosine 45, that's equivalent to 0.025. And F23y is going to be 0.036 sine 45. That's equivalent to 0.025 again. But let's look at the directions. If you look at this component right here, this is in the along the positive x direction, but this is moving downward. It means the y-axis is going to be negative. Okay, so y-axis is negative, and this is our x component. And for the first one, x is negative because it's in the opposite direction. It's going along the negative x direction. So that's why we have negative right here. Now we can go ahead and combine all these components together and see what we come up with. Okay, let's get rid of this part right here. Okay, let's continue. Let's use a different color. Okay, let's continue here. Let's write the x component. So total x is going to be what we are going to have. Previously we had negative 0.054 Newton in the x direction, and then we had plus 0. This is Newton x direction, the Newton y direction. So 0.025 Newton in the x direction, and if we add these two together, that's going to give us negative 0.029 Newton in the x direction, and y direction we are going to have negative 0.025 Newton in the y direction. So this is our x and y total forces. Okay, now we have the forces, and then we want to express the final answer. Like, since we know the forces, we can easily express it. Let's get rid of all of this. Since we have this one, we don't need these things anymore, but we need the diagram. Let's get rid of this part. Okay, let's continue somewhere here. Okay, let's express the final answer. F total is going to be equivalent to negative 0.029 in the x direction, negative 0.029 in the x direction, minus negative 0.025 in the y direction, negative 0.025 Newton in the y direction, and total force is going to be, the magnitude of the total force is going to be square root of ftx square plus fty square, and that's going to give us negative 0.029 square plus negative 0.025 square, and finally we will end up with 0.038 Newton. Okay, so this is our total force. Now we have the force, but we have to find the angle. Okay, we are talking about this one right here, this angle, the angle making with the horizontal. Let's call this one phi. To find the phi, what we do is we put the equation to find the phi is tan inverse f total y component divided by f total x component. Since we know both of them, we can plug that one here and find the angle. So we are going to have tan inverse, the x component is right here, we have the x component, and this is our y component. So let's plug it in this equation. So this is, since this is 2 are negative, it's going to cancel each other, so we can just put the positive value. This is going to be 0.025 Newton divided by 0.029. This is x component and total x component, total y component, and if you calculate this angle, you are going to get 41 degree. So this is the magnitude of the force is 0.038, magnitude of the resultant force, that's 0.038 Newton, and the direction of the force is 41 degree from the horizontal. And that's how we do this kind of problems. I hope this helps. Thanks for watching.